This lesson is the introduction to calculus. And what is calculus? Calculus is a branch of mathematics that involves the study of rate of change. Therefore, the first principle, which is to find the slope of a tangent, which is to find the rate of change of y with respect to x, is defined the first derivative. Thus, instead of saying the slope of tangent, which is using an and, we can say the derivative of f at the point, or we can say the differentiation of f at that point, or we also can say that's f prime. So all those, they mean slope of tangent. So there are many different ways we can write the slope of tangent. One way we can write m as slope of tangent, or we can use function notation, which is called f prime, that represents the slope of tangent m, or we can simply write y prime, which is also a slope of tangent, or we can use Leibniz notation, which is called dy over dx. They are all the same. They all mean to find slope of a tangent. Therefore, instead of saying m equals to limit f of x plus h minus f of x divided by h, I can write as f prime, or I can also write y prime, or I can also write dy over dx. The next terminology that we have to learn is something called differentiable. If we say the function is differentiable at x equals 3, that means at x equals 3, we can draw a tangent line and we can find the slope of that tangent line. If we say the function is not differentiable at x equals 3, that means at x equals 3, when we draw the tangent line, the slope of the tangent line is undefined. So let's look at the three graphs here. The very left-hand side one, you can see at this point, if you draw a tangent line, it is a vertical line. And this type of graph, we call them a cusp. That means at this point, we say the function is not differentiable because the slope of a tangent is undefined. The second graph is this one here. As you can see, the tangent line at this point will be a vertical line again. That means slope of the vertical line is undefined. Therefore, we say the function is not differentiable at x equals to a, and the cause of this is because you have a vertical tangent again. The last graph, we say the function is not differentiable at x equals to a because there is a discontinuity. That means there is no limits. That means the function is not continuous. That means the function cannot be differentiated. One thing that you have to keep that in mind is a function is continuous. At the same time, the function can be not differentiable, just like the first graph on the left-hand side. Okay, the function is continuous. However, at this point, at x equals to a, the tangent line is actually a vertical line. That means the slope is undefined. That means the function is continuous. However, at this point, it's not differentiable. Now, let's try to do some examples again. So this time, we're going to find the slope of tangent to the function fx equals x squared, which is a polynomial function at the point 2, 4. However, we are not going to substitute the value in. We are going to find the derivative first. That means we're going to find the slope of tangent at any x. So first thing we write is slope equals f prime x, which is the derivative of the function, equals the limit. H is approaching to 0, f of x plus h minus f of x divided by h. This time we are not going to substitute any values in. So what we need to find is fx is x squared but we have to find what's f of x plus h. That means x plus h whole thing square. That's expanded. You get x squared plus 2xh plus h squared. And that's substitute in. X squared plus 2xh plus h squared minus x squared divided by h. And that's simplify the numerator. And as you can see, they have h in common in the numerator. We fetch out the h. Since they have a common h, we divide it. Write down restrictions. H cannot be 0. Now, since there's no more denominator, it's 2x plus h, we can put 0 into h. So we say the derivative is actually 2x. So what does that mean by derivative? Derivative means the slope of a tangent at any point along the curve. So at this point, we are finding the slope of tangent at P, which is 2, 4. So slope of tangent, which is f prime x. So slope of tangent, which is 2x. So when x equals to 2, we'll write slope equals to 2 times by 2. We say slope is 4. But since we're in calculus now, so usually we don't write like that. We write like this. We say f prime x equals to 2x. So when x equals to 2, we say f prime at 2 equals 2 times by 2. F prime 2 equals to 4. This implies when x equals to 2, your slope of tangent, which is f prime at 2, equals to 4. Let's verify with the graph. So the dotted line is the tangent line again. Let's find 2 clear points on this tangent line. That's one point, that's another point, and you make a right triangle. You will see, going from this point, you go to the right by 2, you go up by 8. That means your wrong is 2, your rise is 8. So slope equals the rise over the wrong, which is 8 over 2, so slope is 4. The next example, you can see the function is a fraction. So first thing we do is we write down the first principle. Limit h is approaching to 0, x plus h minus f of x divided by h. Once again, we do not write m anymore. We write f prime x. It means the derivative of the function. That means the slope of a tangent at any point along the curve. And the next thing is we want to find what's f of x plus h. So we know f of x equals to 3x plus 4 over x. So f of x plus h will become 3 bracket x plus h plus 4 over x plus h. Expand and simplify. So 3x plus 3h plus 4 over x plus h. And we are going to substitute the f of x plus h into the function. So 3x plus 3h plus 4 over x plus h minus 3x plus 4 over x and divided by h. Now, since we have a fraction over a fraction again, so we're going to change the division line into a division symbol. And we're going to find a common denominator for the numerator. So the common denominator between x plus h and the x will be x plus h times by x. So the first fraction, they have to multiply by an x on the numerator. The second fraction, they have to multiply by an x plus h in the numerator. Divided by h. The next line we do is we're going to simplify what's inside that square bracket, which is the numerator now. So combine them into one fraction. So expand this, 3x squared plus 3xh plus 4x. And just watch out because there's a minus in between them. So every single term in the second fraction has to multiply a negative 1. So you're going to have a negative 3x squared minus 3xh minus 4x minus 4h. And divided by h means times by 1 over h. Next step, we have to simplify the numerator further. And put the h in the denominator. Do not expand the denominator to simplify the numerator. So as you can see, 3x squared and 3x squared, they add up to 0. 3xh, negative 3xh, they add up to 0. 4x minus 4x, they add up to 0. So you only have a negative 4h left. And as you can see from here, they do have a common h in common in the numerator and the denominator. So we divide the h. Restrictions, h cannot be 0. Then we will have negative 4 over x plus h times by x. At this time, we're going to put 0 into the h, and we are not going to write limits anymore. So we say the derivative of this function is negative 4 over x squared. This means you can give me any x value, I will be able to give you the slope of a tangent at any x value that you give me. So at this point, we will see the question asks us to find the slope of tangent at x equals to 2. So we say this, at x equals to 2, the slope of tangent, which is f prime at 2, which is going to be negative 4 over 2 squared. Which is negative 4 divided by 4, it's going to be negative 1. So we say the slope is negative 1. Let's verify it using the graph. Once again, the dotted line is the tangent line. So we find 2 clear points on the tangent line, and then we do rise over wrong. From this point, I have to go down by 5 and go to the right by 5. That means my rise will be negative 5. And my wrong will be positive 5 because I'm going to the right. So my slope equals to rise over wrong. Slope is also negative 1. Therefore, I know the slope of tangent at x equals to 2 on this function will be negative 1. The next example, the function is a radical function. So first thing we do, once again, we'll be writing down the first principle. M equals the limit f of x plus h minus f of x divided by h. And please erase the m and using f prime x. That represents the derivative of the function. That means the slope of tangent at any point along the curve. The next step we have to do is we have to find out what's f of x plus h. So given fx equals to square root of x minus 3. So f of x plus h will become square root of x plus h minus 3. And that's substitute into our first principle. As you can see here, we have square root function. So in order to simplify it, we have to get rid of the square root. How do I get rid of the square root? I have to times by its conjugate. So the conjugate will be x plus h minus 3 plus x minus 3 square root. And we have to do the same thing to the denominator. Then we have to simplify the numerator. As you can see here, in the numerator, it is actually a difference of squares. So let's put the denominator in first, and please do not expand it. So the numerator is a minus b times by a plus b will become a squared, which is x plus h minus 3 whole thing squared, minus square root of x minus 3 whole thing squared. And the next step we can do is get rid of the square root. Now, you have to be very careful when you try to simplify the numerator. Just to see, there is a negative sign in the middle. That means when you take out the brackets, you have to do -1 times by x and -1 times by -3. So you're going to have x plus h minus 3, and you're going to have minus x plus 3. And just copy down the denominator. Don't change it. And that's simplify the numerator. X minus x will become 0. -3 plus 3 becomes 0. So now you're left with the h on the numerator. So f prime x equals the limits. H is approaching the 0. H is left on the numerator. Now you can see from here, both the numerator and denominator, they have a common factor h. So we can divide the h, write down restriction, h cannot be 0. So what's on the numerator now? It's a 1. At this point, we need to see whether or not we can put 0 into h. As long as the denominator does not become 0, then we can put 0 into h. So if we put 0 into h now, we have x minus 3 square root. That's not 0. Plus another square root x minus 3. It's not 0. So that means we know it is ready to do substitution. And when we substitute 0 into h, we do not write limits anymore. So f prime x will become 1 over square root of x plus 0 minus 3 plus square root of x minus 3. So f prime x will become 1 over square root of x minus 3 plus square root of x minus 3. We have 2 of the same square root, so I can say 1 over 2 square root of x minus 3. If the question wants us to find the derivative, then we have to rationalize it. So rationalizing it means you have to times by another square root of x minus 3 over square root of x minus 3. So your answer will be square root of x minus 3 over 2 bracket x minus 3, if you need to rationalize it. However, this question is only to find the slope of tangent. They didn't ask us to find the derivative. So I just need to do substitution by putting the 7 into the x to find the slope of tangent. So we say slope of tangent equals f prime as 7 equals to 1 over 2, 7 minus 3. I'm going back to this equation here, so it's easier. Therefore, m equals to 1 over 2 times by square root of 4, which is 2 times by 2, which is 4. So slope of tangent, which is 1 over 4. If you want, you can verify with the graph again. Just pick 2 clear points on the graph. That's one, that's another one. You do a right triangle, which is also called the right triangle, to find out the rate of change. So from this point, I have to go 1, 2, 3, 4, 5, 6, 7, 8 units to the right and 2 units up. So I can write as this: 8 units to the right, which is your wrong, 2 units up, which is your rise. So slope equals to rise over wrong, which is 2 over 4. Slope is 1 over 4. So therefore we can say at x equal to 7, the slope of tangent on the function square root of x minus 3 is 1 over 4. Now, let's do a summary. So if the function given is a polynomial function, when you are using the first principle to find the slope of tangent, all you need to do is expand the polynomial function and simplify, and after that, you can substitute 0 into h to find the slope of tangent. If your function given is a rational function, which is a fraction, then you combine the fractions by finding the common denominators and you simplify. And after that, you put 0 into h and you find the slope of a tangent. The last one, if a function is a radical function, that means you see a square root, all you need to do is times by its conjugate to get rid of the square root, this process called rationalization, and then you simplify it and you substitute 0 into h to find the slope of a tangent. Therefore, you will find a derivative of a function, which is the slope of a tangent at any point along the curve.